Hello and welcome to the MecSoft demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mecsoft.com. Without further delay, we invite you to sit back and enjoy the demonstration.
Now, these steps that we're going to talk about is applicable in our plugin for Rhino, which is RhinoCam, or our standalone flagship product, Visual CAD Cam, or Visual Cam for SolidWorks, or it could also apply to our Libre Cam product as well. So what I have here currently is a prismatic part, and I have a few toolpaths programmed in here, and I'm looking to program the pocket, the blind pocket in here. And we'll talk about the depths per cut. So as you go into your cut levels tab, you have the control to specify your cut depths. So the total cut depth in here is defined, is set to be 1 3/4 inches. So that's the total depth of the pocket in here. And now this total depth can be split up into rough depth and finished depth. So as you adjust the rough depth parameters, and the finished depth automatically is computed. So basically a rough depth plus finished depth equals to the total depth. And as you vary this in the slider control, or as you input a value in here, you will notice that it automatically computes the finished depth based on the rough depth that you entered in. Now the rough depth in here can be split up into multiple depths per cut. As you can also see in the graphic preview here, it shows the rough depth can be split up into multiple levels. So typically on a rough depth, you may want to take a deeper cut, and on the finished depth, you can further break this down into multiple depths per cut. So you may want to take smaller amount of passes as you get down towards the floor of the pocket. So you have precise control for depth per cut for rough depths, as well as depth per cut for finished depths. Now on this particular part, we programmed a toolpath in here, and as you noticed, the cut levels, the rough depth is set to 1 inch. It's split up into 2 passes of 1/2 inch each, and the finished depth is split up into 3 passes of 1/4 inch each. So if we take a look at this toolpath and look at the toolpath display in levels, you will notice that the rough depth is programmed in 2 levels. So we are taking 1/2 inch cut. So the first cut is at 3/4 inch down from our work 0, and the next cut is 1 1/4 inch, and then the finished cuts are split up into 3 cuts of 1/4 inch each, so you can get really fine control. And I'm going to switch to the wireframe view in here so you can actually see the cut levels. So there are your rough depths. We have 2 cuts for the rough depth, and then we have 3 additional cuts for the finished depths right in here. So you have the precise control of being able to adjust your rough depth and finished depth. If you want to make it much smaller, further reduce the depth per cut, you can change this, and when you generate the toolpath, you will now notice that there are more number of passes on your finished cuts, and you can also step through them by taking a look at your Z-level display in here.
I just want to break in and explain why you might ask, if you're cutting soft materials, it's not that important, the ability to split that into roughing and finishing. But if you're cutting metal and hard metal, then it becomes more important because of tool deflection. What you want to do is, as you approach the floor of the pocket, you want to take smaller amounts of material that can keep your, the actual finish on the part true to the actual part design. So that's why we do it. But if you're cutting soft material like wax or foam, you probably don't even have to worry about it, and just use the rough cut depth. Thanks, Uday.
Thank you, Joe. Now on this particular part, we have an island in here, and the island top is at a different elevation as compared to the top face of the pocket. So we have an option which is called clear island tops. So when this option is selected, you will notice that an additional cut level is inserted automatically at the top face of the island. So this is a very nice feature that you have available in pocketing and also in facing operations. So where you have the clear island top, so you can see that there is an additional pass at 1/2 inch where the island top is, and then it still honors your depth per cut that you specified for the rough depths and also your finish depth per cut. So selecting clear island tops will honor the Z height on the islands. Each of the islands, you could have one or more islands, and for each island top, it'll insert a cut level, an XY pass at that island top cut level, so to clear it out, so you don't have to create an additional operation for programming it. Now, the next thing I would like to talk about here is how we can take advantage of a 3D model to determine depth. Now, to demonstrate this, I'm going to go into to our Visual Cam plugin for SolidWorks, and as you can see here, I have a part which has multiple different pockets, and the pocket, the depth of the pocket is not consistent for all of them. You can see there's, these two pockets have a certain depth versus these two in here. So rather than having to program these pockets in multiple different operations, you could program them all in one single operation and take advantage of this use 3D model to detect depth. So when this is selected, it'll automatically determine the depth of each of these pockets based off the solid geometry or the surface geometry that you have, and you still have the control ability to specify depths per cut. So in this particular case, I've specified use 3D model to detect depth and specify the depth per cut of 200 thousandths. So as we take a look at this toolpath in here, you will notice that there is 2 levels for the pocket, the deeper pocket in here, and you can see that there's just 1 cut level for each of these the pockets that have a shallower depth, and again there's 2 levels for the deeper pocket. So rather than having to program multiple different operations, you can take advantage of using 3D model for determining depths, and this is available in pocketing and also other 2.5 axis operation types in here.
So the next concept that we will cover is in terms of the location of the cut geometry. Now, since you're doing 2.5 axis machining, it is likely that you have 2D geometry as opposed to 3D geometry. And so now the question becomes, how do you identify where is this geometry that you're selecting? And what we're trying to show with these 3 pictures on this slide is that you have the option to say the geometry that I've selected, which is indicated by the orange color on these slides. On the first picture on the left, you've selected the geometry at the top, and then you've defined a depth of cut. And so the system knows that it's going to start there, and you've given it a depth of cut. And on the second picture, you've selected geometry at the bottom of this particular pocket, and you've specified a depth of cut. So basically what you're defining here is saying, is the geometry at the top or is it at the bottom? And there may be situations where you're not able to define the geometry either at the top or the bottom. You just have, the 2D geometry on the last picture, which is sitting at 0 on the XY plane. And let's say you have a stock height of 1/2 inch. You might want to say, I want to start 1/2 inch above and cut down to a certain, depth of cut. So in this case, we have an option called pick top, which allows you to say my top is at 0.5 in the Z, and then I'm going to specify a depth of cut. So that way you select the geometry actually at the bottom, but you specify the pick top and a depth of cut. And these concepts will also become a little bit more clear as we go through some examples.
Thank you, Krish. Folks, now we'll go over and take a look at a few examples on how you can effectively use the location of cut geometry in 2-axis programming. So I have a prismatic part in here where I have 3 different pockets, and I'm going to go over how we could use the location of cut geometry for at top, at bottom, and also pick top in these three pockets. Now the first thing I'm going to cover is location of geometry at top. And in this particular example here, we are trying to program the pocket or the one that's farthest away from us, closer to the origin. So the control geometry, which is the part region we've selected here, is at the top edge of the pocket. So when you have the control geometry selected at the top edge of the pocket, under your cut levels tab, you would want to set the location of cut geometries at top, which means when you specify a depth, your cuts would begin from the top, cut down to the specified depth. So here the depth is set to be 1/4 of an inch, and we've set it to go in 2 levels. So it's going to start from the top, go down to a depth of 1/4 of an inch. So when you pick at top, your cuts will begin where the control geometry is. In this case, it's your part region, and goes down to the specified depth. So we have 2 levels going from 0. The first cut is an 1/8 inch, and then down to the floor, which is 1/4 of an inch. So if you have a face edge or a sketch that you could select that's at the top of the pocket, then you'd want to pick that, and then in the location of cut geometry, you'd want to choose as at top. Now, you could also select, if you have a blind pocket in here, you can select the floor. In this particular case, you can see that there is a chamfer on the top edge of the pocket. So I wouldn't be able to select the exterior edge because you would end up overcutting the pocket if you pick this as your control geometry. So in this particular case, I could be selecting a flat area, which could be the floor of the pocket, or I could be selecting a chain of face edges in here. So the second example demonstrates here where we have the geometry selected, the control geometry selected at the floor of the pocket. So when you have the control geometry, which is your part region, at the floor, you would want to make sure that in the location of cut geometry, you pick at bottom. Now, had I selected at top, then the toolpath would begin here and cut further in. So you want to make sure that if you're picking the control geometry at the floor of a pocket, you need to make sure under location of cut geometry, you'd want to select at bottom. And this will ensure that the cuts will not cut below this floor, and all your cuts will remain above it. So in this particular case, the total depth again is set to be 1/4 inch, and it's split up into 2 passes of an 1/8 inch. So as you take a look at the toolpath and the toolpath in levels, you'll notice that the first level is an 1/8 inch from the origin, which is your Z0 right here. You have 2 levels, and the last cut would be at bottom where your control geometry is located. Now the next option we have in location of cut geometry is the ability to specify the location where you want to begin the cuts from. That's called pick top. In this particular example, I have the part region selected where the edge of the chamfer ends, the base edge of the chamfer. So this is neither at the top of the pocket nor at the floor of the pocket, the control geometry what we've selected. So we would essentially want to start at the top face of the part and then cut down to a specific depth. So in the cut levels tab, you would pick location of cut geometry as pick top, and you could specify the top location, or you can even graphically pick where the top needs to be. So in this particular case, I can just pick the top face, and that's established based on where your work 0 is set. That's 0. And now I can establish the depth in here by selecting the top face and then the floor. So that establishes a depth of 1/4 inch, and again you can break it up into multiple depths per cut. So by selecting pick top, the part region is essentially moved to the location where you want to begin the cuts from, and you'll be cutting to the specified depth from the start of cut location, which is going to be Z0 in this particular example. So this will result in 2 levels again, and it goes down to a total depth of 1/4 inch from 0, 0 being the location of pick top. So depending on the type of part geometry that you're working on, you could choose between at top, at bottom, or pick top whichever is most ideal and applicable for the part that you're programming. Now the next thing I'm going to demonstrate here is how we could work with some 2D geometries to establish at top, at bottom, and pick top. Now to demonstrate this, I'm going to go ahead and switch over to RhinoCam again. So I have a prismatic part in here which has a stepped pocket. So we have 2 pockets in here. Now consider that you were only supplied with a 2D drawing of this part and not a solid model. So in this particular case, you'll notice that all of the geometries that you're looking at is just on the XY plane. There is no depth or thickness to it in here. So we have defined a stock which is going to be 1 inch in thickness. And for the first pocket, as you noticed in here, we would want to cut down to a depth of 1/4 inch from the top of the stock. So to cut down to a depth of 1/4 inch, I'm going to pick this curve which is sitting down at the floor of the stock, which is the bottom of the stock. Now I can't use at bottom in here because if I specify at bottom, it's going to cut down to this level. So in the cut parameters under the cut levels tab, I'm going to set the pick top at the start height, which is the top of my stock, which is going to be 1 inch. And I only want to cut down 1/4 inch from the top of the stock. So I put in my total depth as 1/4 inch, and I can further control the depth of cut as we talked about earlier. So in this particular step, it's going to start at 1 inch and cut down to 1/4 inch. So basically it's going to leave 3/4 inch material from your zero, the zero being set at the bottom of your stock material in here. So you'll notice that as you take a look at your cut levels, a Z-level display, it's cutting only 1/4 inch from the top of your stock. So you can take advantage of pick top in this particular case. So I'm going to run a quick simulation in here, and you will notice that it's only cutting down 1/4 inch from the top face of your stock. Now one of the other ways you could have also done is take this geometry, the part region, and have it moved to the top of your stock material. So if you had it moved to the top of the stock material, you could have chosen at top because the geometry would have been at the top. So rather than having to physically move the part region in your CAD system here, you could take advantage of the location of cut geometry. So we've already programmed the first pocket, the first step on the pocket. Now let's take a look at the second pocket in here, which starts where the first pocket ends, and it's cutting further down to a specific depth of 1/4 inch. So we'll see how we could program this using the controls we have in the location of cut geometry. Now for the second pocket, I'm going to pick the inner curve as the control geometry, and in the cut levels tab, now I'm going to set the pick top to be 3/4 inch. As we've already cleared out the first 1/4 inch from the top face of the stock, which is 1 inch, so the balance, the remainder remains is 3/4 inch, and we want to cut down 1/4 inch from a height of 3/4 inch. So basically you would be cutting from 3/4 inch down 1/4 inch, so resulting in a total depth of 1/2 inch, leaving 1/2 inch from the bottom of the stock. So you'll notice that it cuts only 1/4 inch from a height of 3/4 inch. So you can effectively use the controls that you have under location of cut geometry for specifying, where you want to begin the cuts from and how deep you want to cut if you're working with just a 2D geometry in here.